Hey guys, this is Einar. I hope you're doing great today and welcome to this tutorial in which we're going to be talking about confidence intervals. Now, specifically, we're going to be talking about confidence intervals that make use of the normal distribution in order to create guesses around the x-bar, which we're going to be calculating using this sample over here, and how sure we can be on this x-bar based on a lower limit and an upper limit over a guess. Now, because we're using the normal distribution, it'll look something like this, a symmetrical distribution with critical z values that we have found in the z tables. And if you don't know what I'm talking about, there are earlier tutorials that you need to look at. So that's why we have z here in the formula. And what we're going to do is we're going to take our average here, plus, for the upper limit, our z value multiplied by the standard error. And for the lower limit, it's going to be minus our z value times the standard error. So I think we're just going to get right to it and start calculating, and this will become more clear for you. The first part of the formula that we need is n, because the size of our sample is going to determine how sure we can be of our guess, and therefore it's also going to determine the size of our confidence interval. So I'm going to my n here in the calculation square, I'm going to equal to, and I'm going to count the number of observations I have. So I select my data set like this, all the way down. Okay. Close that parenthesis, and I find that we have 147 observations. Pretty okay sample. The average number of Facebook friends that they have, well, we're going to need that because that's what we're guessing. Select my data as before. Close that parenthesis, and I find that on average, our guess is that a Tango Dancers has 245 Facebook friends. So this is this part of the formula. Now furthermore, it's not only the size of our sample that determines how sure we can be of our guess, it's also the variation around our x-bar. So I'm going to have to calculate the standard deviation using that formula there. Select my data. It's a lot of selecting data in this tutorial. And I find that we have a standard deviation of 412 Facebook friends. So basically, if I told someone now that, okay, I think that we have 245 Facebook friends in our dataset for Tango Dancers on Facebook, they would first say, well, how many Tango Dancers have you asked? How can you be so sure? Well, I would say, okay, I've asked 147 people, so I could be pretty sure. But then they're going to say, well, you know, some people have loads of Facebook friends and others have almost none. What is their standard deviation? How much does this vary? Well, I can tell them my standard deviation. And based on this, I can create a standard error that I can use to create a confidence interval to be even more clear about how sure I am of my guess. So that equal to, we need a standard deviation divided by the square root of our n, and I get 34. And that's basically everything we need for our formula. We have our guess of the number of Facebook friends that Tango Dancers have, that's our x-bar, 245. We have our critical z values down here, and I'm going to talk more about them later. And we have the standard error right here, based on our variation around the mean and the size of our sample. So I begin, select this part of the table, and I get that our guess is 245. Now for the lower limit, I'm going to write equal to our guess, and this time it's minus because we're talking about the lower limit. So minus our critical z value multiplied by our standard error, which is right there, and I get a lower limit of 178. Now, the critical z values here at 1.96, how can I know that? Well, I know that from tables that have been created for the normal distribution that show us at how many percent we have in the tails at different critical values. There are earlier tutorials on this that you need to check out if you're not sure about that. So we move on to the upper limit. We have our x-bar, and because we're working with the upper limit, I'm going to have a plus there. Our z value multiplied by the standard error, right there. Hit enter and we get our upper limit of 311. Now, what does this confidence level mean? Let's think about that. Well, a confidence level at 95% means that if I conducted my sample, I did this sample over and over again, 100 times, I can now say that in 95 of these 100 times, we would get an average that was in between these two numbers here. So our average would in 95 out of 100 times fall within this limit. And if you translate that to the standard normal distribution, we can see we have 1.96 there minus and 1.96 there plus, and then we translate this to the number of Facebook friends. So the 0 here in the middle becomes our guess, which we're creating an interval around, and then the lower limit will become 178 and the upper limit will become 311. And because we're working at 95% confidence level, I'll have 5% outside my interval. So 2.5% in that tail and 2.5% in that tail. So basically that's how confidence interval works. We're going to do this for another interval. So I'll write equal to. Same x bar as before, that's our guess, it's not going to change. Okay, same formula. I select my x bar. That's the lower limit, so we take minus. And this time our critical value has changed to 1.65, multiplied by the standard error, which is 34. And we get 189 as our lower limit. Now for the upper limit, same formula, 245, plus, this time because we're working with the upper limit, our critical z value, which I found in a table from before, multiplied by our standard error, which is right there. I hit enter and we get another interval. Now if we compare these intervals by finding the range, I'm going to show you something. We get a range of 133 Facebook friends in the first interval at 95% confidence level, but at this other lower confidence level at 90%, we get a smaller interval, only 112 people in our interval. What does this mean? Does this mean that we are sure in this guess and this one? Well, not really. We have a smaller interval, that's for sure. But we also have a lower confidence level. So this time I can only say that in 90 out of 100 times, my average would end up within this interval. And that makes sense because it's smaller than this interval. So the larger my interval becomes, the more sure I can be that the average is located somewhere inside of this interval. So basically that's how confidence intervals work. I hope you can play around with this, have some fun. Try, for example, increasing the standard error to some really large number, like 120. If my standard error was 120, you can see the ranges here. My interval size increased a lot. And meanwhile, if I had a standard error of only 10, it would decrease a lot. So the standard error, which is dependent on the standard deviation and the size of our sample, will have a large effect on the size of our intervals. So play around with that, try to figure out why, and I hope you have a really great night. Bye-bye.